All right, so circular motion is quite different from the rest of the motion that we have analyzed up to this point in the year. Circular motion generally describes the motion of an object, ideally in a circle, around a fixed point. So this might be the object over here, and then if that were a ball, it might be connected to a rope to the center point. And that ball would move along a circle in relation to that object in the center. So, centripetal acceleration is the acceleration that causes motion um, in circular motion problems, and it's caused by a centripetal force. In this case, the centripetal force is the tension of the rope pulling on that ball, and it causes the centripetal acceleration. So now, although um, the ball over here is accelerating because of the centripetal acceleration, it's not actually moving any faster or slower. There's no change in its speed. So in this case, acceleration is actually defined as the ball's change in direction, because like over here it's going in this direction tangent to the circle, but when the ball gets over here, it'll start moving in this direction. Keep in mind that velocity is represented by a vector, which has two components, a magnitude and a direction. So centripetal acceleration does not change the magnitude, but it will change the direction that the object is moving in. Now, moving on to the conceptual question number 9 in the textbook, which is the question that we will be addressing in this video. This question asks us, well, it tells us that there's this apparatus that's set up. There's this stationary thing in the middle, right? And then there's this beam, and two jars of water are placed upside down with floats in them. Now, the question is, when the arm is rotated, which way will the floats move? And does it make a difference which way the arm is rotated? So to answer this question, let's first draw a force diagram for the floats. Now, when we're drawing force diagrams for centripetal motion problems or circular motion problems, it's generally best to define the axes as the y-axis and the r-axis, which is like a radial axis. And the r-axis refers to sort of the radius of the circle, the pull, the centripetal force that that is acting on that object that originates from the center of the circle. And it's not defined as an x-axis because otherwise that axis would sort of keep spinning, so it's inconvenient to define it that way. So for that reason, we define it as a radial axis. So let's draw a force diagram for the float. First, let's delete this, because when the float is at rest, there's only two forces acting on it. The first one is the force of the water pushing up on the float, and the second one, the first one was a buoyant force. The second one is the force of the earth pulling down on the float. And these two are equal for now, and so there's no vertical motion or acceleration of the float. So this is when it's stationary. However, when the apparatus starts to turn, there will be a centripetal force applied to the float on the r-axis, and then this centripetal force will pull the float inwards toward the center of the apparatus. So to answer the question that was posed, when the arm is rotated, the the floats will move in toward the center of the circle of the apparatus, and this float will do the same thing because its force diagram is just the mirror image of the force diagram shown here. Now, clearly, it by now after we've drawn the force diagram, it doesn't matter which way the arm is rotated because there will still be this centripetal force being applied to both floats that will pull them inwards. So both floats will always be pointing inwards when the apparatus starts to spin.